Hi, welcome to the new section Laplce Transform. I'm Sangeeta Singh, Assistant Professor, NSS College in Nemmara. Today, I would like to explain about the topic Laplce Transform, its definitions, its applications, etc. Let's consider what is the application here. Mathematics plays a decisive role to understand the behavior and working of the electrical and electronic system. The differential equations are prominently used for this defining control system and are easy to solve. But complexity arises while solving higher order differential equations. To solve such higher order differential equations, the mathematical method that proved to be effective is the Laplce transform. So, Laplce transform is very useful in the field of electrical and electronic system. Okay. Definition for the Laplce transform. Let f of t be a function of t defined for all non-negative values of t. Then the Laplce transform of f of t is denoted by L of f of t, that is a capital this type letter, or L of EF, L of f of t or L of f, and is defined by L of f is equal to integral 0 to infinity e raised to minus st into f of t dt, provided that the integral exists. What is this s here? S is a real parameter or real number. This parameter s is a real number or a complex number. Okay, so this is a definition for the Laplce transform. What is the transform? L of f is equal to integral from 0 to infinity e raised to minus st into f of t dt. Next, we have to notice these carefully. That is, L of f is a function of es. So, I can write this as capital F of s. That is a Laplce transform of a small f of t, which is 0 to infinity e raised to minus st f of t dt. This is called f of s is a Laplce transform of small f of t, and also we can say that the small f of t is the inverse transform or inverse Laplce transform or inverse transform or inverse of f of s. It is denoted by f of t is equal to L inverse of f. Okay. Next is very important transform of some elementary functions. First of all, we have to check what is L of 0. From the definition, we know that L of f of t is equal to L of f of t is integral 0 to infinity e raised to minus st into f of t dt. E raised to minus st into f of t dt. And here L of 0, L of 0 means in place of f of t, here f of t is equal to 0. So this is integral from 0 to infinity e raised to minus st into 0 dt. We know that this is always 0. Okay. So look at the second one. What is second one? L of 1. We have to find out what is L of 1. L of 1 is from the definition 0 to infinity e raised to minus st into f of t in place of that is 1 dt. So integral of e raised to minus st, that is e raised to minus st divided by minus s from 0 to infinity, which is equal to minus 1 by s into e raised to minus infinity. Infinity I am substituting here, minus e raised to 0, which is equal to minus 1 by s, and this is 1 by e raised to infinity minus e raised to 0 is always 1. And this is clearly what is e raised to infinity? E raised to t is an increasing function. So e raised to infinity is increasing function, e raised to infinity is actually infinity. So 1 by infinity in turn that is goes to 0. So minus 1 by s into 0 minus 1 which is equal to 1 by s, where s is greater than 0. Next, we can consider what is L of t. What is L of t? Laplace transform of t, which is equal to integral 0 to infinity e raised to minus st into t dt. So we have to substitute that. So I am writing this as integral from 0 to infinity t into e raised to minus st dt. So that is the integral of two function, that is t into integral, that is e raised to minus st by minus s. Then integral of uv is actually uv1 minus u dash v2 plus u double dash v3 etc. What is u here? U is the first function. Function എടുക്കേണ്ടത് ഡെറിവേറ്റീവ് എടുത്തു കഴിഞ്ഞാൽ അത് ഡിക്രീസ് ചെയ്ത് ഡൊമിനേറ്റ് ചെയ്ത് പോകുന്നതാണ് നമ്മൾ യു ആയിട്ട് ചൂസ് ചെയ്യേണ്ടത്. അപ്പം അങ്ങനെയുള്ള കേസിൽ ഇവിടെ ടി ആണ് അത് എലിമിനേറ്റ് ചെയ്ത് പോകുന്നത്. ടിയുടെ ഡെറിവേറ്റീവ് 1, പിന്നെ അതിന് 0 ആണ്. സോ യു എന്ന് പറയുന്നത് ടി ആയിട്ട് ചൂസ് ചെയ്തു. സോ യു v1 എന്ന് പറയുന്നത് ഇൻറ്റഗ്രൽ ഓഫ് v, v2 എന്ന് പറയുന്നത് ഇൻറ്റഗ്രൽ ഓഫ് v1. ഓക്കെ, so u v1 is actually here it is t into e raised to minus st by minus s minus u dash is 1, v2 is again ഇതിൻ്റെ integration e raised to minus st by s square വരും. അടുത്ത ടേമിൽ 1ൻ്റെ ഡെറിവേറ്റീവ് u ഡബിൾ ഡാഷ് എന്ന് പറഞ്ഞാൽ 0 ആണ്. അപ്പോൾ ഇവിടെ വരുന്നത് minus e raised to minus st by s square, and this is from 0 to infinity actually. So this is ഇവിടെയും 0 to infinity കൊടുക്കുക. എന്ത് വരും? minus 1 by s into infinity into e raised to minus infinity minus 0 വരും. പിന്നെയുള്ളതിൽ minus 1 by s square into e raised to minus infinity minus e raised to 0. Actually this limit is infinity into 0 form. This is actually 0. By L'Hopital rule, this can be as this is equal to 0. This is equal to 0. So this is minus 1 by s square into this is 0 minus 1. So this is 1 by s square, where s is greater than 0. Okay, so this is the Laplace transform of t. Next we have to check the Laplace transform of t raised to n. So from the definition 0 to infinity e raised to minus st into t raised to n into dt. Actually t raised to n into first function into integral of 0 to infinity e raised to minus st dt minus integral from 0 to infinity n t raised to n minus 1 into, that is integral of e raised to minus st by minus s into dt. So this is equal to, this is actually t raised to n into e raised to minus st by minus s from 0 to infinity. This is same as what? This is same as minus integral 0 to infinity, n is taking outside, n by plus here, n by s, t raised to n minus 1 into e raised to minus st into dt. Okay, so by applying the limit we can see that this is 0 plus n by s into integral 0 to infinity t raised to n minus 1 into e raised to minus st into dt. I can write this as n by s into, this is the Laplace transform of t raised to n minus 1. t raised to n minus 1. Similarly, what will be the Laplace transform of t raised to n minus 1? This is integral 0 to infinity e raised to minus st into t raised to n minus 1 into dt, which is equal to integral 0 to infinity t raised to n minus 1 into e raised to minus st into dt, which is equal to t raised to n minus 1 into e raised to minus st by minus s from 0 to infinity minus integral 0 to infinity n minus 1 into t raised to n minus 2, again e raised to minus st divided by minus s into dt. Okay, so this is equal to, which implies this turn to 0 and this is minus plus I marum plus n minus 1 by s integral 0 to infinity t raised to n minus 2 into e raised to minus st into dt. We can write it as n minus 1 by s into Laplace transform of t raised to n minus 2. Proceeding this way, we can see that what is Laplace transform of t raised to n? That is n by s into Laplace transform of t raised to n minus 1, and which is same as n by s into, what was this one? This is n minus 1 by s into Laplace transform of t raised to n minus 2, and what will be the next step? N by s into n minus 1 by s into n minus 2 by s into Laplace transform of t raised to n minus 3. Similarly, continuing like this, we can see that Laplace transform of t raised to n implies n by s into n minus 1 by s into n minus 2 by s into etc. into 3 by s into 2 by s into what? 3 by s into 2 by s into Laplace transform of t. Laplace transform of t. What was the Laplace transform of t? So which implies, which is equal to Laplace transform of t raised to n is equal to n by s into n minus 1 by s into etc. 3 by s into 2 by s into 1 by s square, which implies n factorial divided by s raised to n plus 1. N factorial divided by s raised to n plus 1. So these are the explanation, these are the formulas we can derive from the Laplace transform definition. Okay, so next move on to Laplace transform of e raised to at. That is, we have to check what is Laplace transform of e raised to at. Consider the next one, next formula, Laplace transform of e raised to at. So here integral 0 to infinity e raised to minus st into e raised to at dt, which implies integral from 0 to infinity e raised to a minus s into t dt, where s is greater than a. Since s is greater than a minus s is negative, or s minus a is positive. So the integral is e raised to a minus s t divided by a minus s from 0 to infinity, which implies e raised to a minus s into infinity minus e raised to 0 divided by a minus s. This is negative, so I can write it as minus of s minus a. So this is negative value into infinity is e raised to, this turn to e raised to minus infinity, which implies that is 0. So 0 minus 1 by a minus s, so that is 1 by s minus a. So this is a formula for e raised to at. Okay.